Hi students, welcome to this section where we deal with averages. Now average is also called the arithmetic mean. There are other types of averages such as geometric mean and harmonic mean which we'll be dealing in future sections. Alright, now let's get started with average. Now say that you have a set of numbers. Now what would be the average of that set? It would be where the center point lies, or it can also be thought of as a number that can replace every number in your set without changing the total. Alright, let's try to understand this with an example. Say you have a set of numbers. So that's 21, 18, 15 and 16. So you have these four numbers. Now what's the average of this set of numbers? The average is equal to the sum of these numbers divided by the number of values. So over here you have four values, right? So the average of this set of numbers would be the sum divided by the number of values. That's 21 plus 18 plus 15 plus 16 divided by 4, and that gives you 17.5. So what does this mean? It means that the center point lies at 17.5 if the given set of numbers is this. Or you can imagine it in different ways. For example, you have 4 people and the number of marks scored out of 25 by the 4 people is 21, 18, 15 and 16. Then the center point of the marks obtained would be at 17.5. Now let's think of this way of average. Over here we have said that it's a number that can replace every number. So we have over here 4 numbers without changing the total. So what's the total over here? That's 21 plus 18 plus 15 plus 16. That's equal to 70. So what number can each of these numbers be replaced with so that the total remains 70? That would be 17.5. So what does that mean? It means if I replace every number by 17.5, that's 17.5 plus 17.5 plus 17.5 plus 17.5, and that also adds up to 70. So you can see that the total has not been changed. So quick recap, the average is the sum of the numbers divided by the number of values. Alright, now let's see some special cases with respect to average. So over here we have 3 cases. This is the case where you have consecutive numbers. In this case you have consecutive even numbers, and over here you have consecutive odd numbers. Alright, let's observe these 3 scenarios. Let's take some examples. Over here I have 27, 28, 29, 30 and 31. So in this case I have an odd number of numbers, right? Because I have 5 numbers. 1, 2, 3, 4, 5. Now let's take one more example where I have an even set of numbers. That's 30, 31, 32, 33, 34, 35. All these are consecutive numbers, right? And over here I have 6. So that's an even set of numbers because 6 is even. Alright. Now if you have odd number of consecutive numbers, the average would be the middle value. That's 29 over here. So you don't need to calculate it. We have seen that average is sum by number of items. So if you do 27 plus 28 plus 29 plus 30 plus 31 and you divide this by 5, you will get your answer as 29, right? You can try it out. Now one more way in which you can think of this is you can write 27 as 29 minus 2, 28 can be written as 29 minus 1, then you have 29, and 30 can be written as 29 plus 1, and 31 is 29 plus 2. So when you add these up, you can see that you have a minus 2 over here and a plus 2 over here, and you have a minus 1 over here and a plus 1 over here. So if you add these up, you will get 29 into 5, and you're dividing with 5, and that's why the average is 29 itself, and that's your middle value over here. Alright, now let me make some space over here. Now what would be the case when you have an even number of numbers? So over here you have 6 numbers. In this case, the average would be the average of the middle 2 values. That's 32 plus 33 by 2. And because these are consecutive numbers, you don't need to actually add and then divide by 2. The value over here would be the midpoint between these two. That's 32.5, right? You have 32 over here and 33 over here. So the midpoint would be 32.5, and that is your average. And this is how you get it. That's 32 plus 33 by 2. Alright, let's proceed. Now let's take the case where you have consecutive even numbers. Let's take an example. You have 4, 6, 8, 10 and 12. Over here you have 5 numbers. So this is the case where you have an odd number of numbers. And let's take one more example. Over here you have 6 numbers. So in this case you have an even set of numbers. Now in this case the average would be the middle value, that's 8 over here, and in this case you just need to take the mean of the middle two values. So that's 12 plus 14 by 2, which gives you 13, and even logically it's the midpoint between 12 and 14, that would be 13, right? And over here you just need to take the middle value, that's 8 itself. So if you have 5 even numbers which are consecutive, the middle value will be your average, and if you have 6, you just need to take the mean of the middle two values. Alright, now let's take a few odd numbers. So I have 3, 5 and 7. So in this case I have odd number of numbers, right? Because I have 3 numbers. And let's take one more example where I have an even set of numbers and all of these are odd consecutive numbers, right? Now this similar to what we have learned before. In this case your average will be 5, which is the middle value, and in this case your average will be 10, which is the middle value between 9 and 11. Hi students, in this video let's discuss the two most important types of average based questions. Alright, now for this let's take the case of football matches. Now a football match is 90 minutes long, and say we track how many minutes a player runs in games. So that's for a particular player. Alright, now what's the first type of question you could get? For example, if it's given that till the 5th game is over, the average minutes that this person ran is 65 minutes. Alright, so this is when it's over. And it's also given that in the next game, that is in the 6th game, the person ran for 70 minutes. And we are asked to find the new average. So this is one type of question. And the second type of an important question is, say it's given that after the 5th game, the average minutes that this person ran is 65 minutes, and it's given that after the 6th game the average changed to 66 minutes, and we are asked to find the minutes that this particular player ran in the 6th game. So these are the two important types of questions, and we'll see how to quickly attack and solve these type of questions. Alright, now let's keep this aside and let's get started with the first question. So it's given that when the 5th game was over, the average was 65 minutes, and in the next game he ran 70 minutes. Alright, now let's see an important way in which we can visualize average based concepts, and that will help us to solidify our understanding. Now we have seen that the average is a number that can replace every number in a set without changing the total, right? We have seen that. So over here it's given that when 5 games were over, the average was 65 minutes. So I can represent it like this, right? So each circle represents one game, and I can write 65 for each of these, because as we have seen, average is the number which can replace every number in a set of numbers without changing the total. Alright, now it's also given that in the next game the particular player ran for 70 minutes. Alright, now we need to find the new average. Now before we go ahead and see the conventional method, let's first approach this in a logical manner, and this will help us to solve these type of questions very fast. Alright, now let me represent the 6th game over here and let me give 65 minutes to it, right? So I had 70 minutes, so I am just giving 65 minutes to the 6th game. If that was the case, the average would have remained 65, right? You can see that still every game has 65 minutes inside it, and then the average would still be 65, right? Now how many minutes am I left with? I have 70 over here and I just gave 65 over here, right? So I am left with 70 minus 65, that's equal to 5 minutes. And remember, when I have the average inside it, it should be the same number for all the 6 games, right? So I need to divide this 5 minutes to 6 games, right? So I can give each game plus 5 by 6, right? So let me add that to each of these 6 games, and then I get my new average as 65 plus 5 by 6, which is equal to 65.8. So that solves the first type of question, And you can see that this is much faster than the conventional method. What's the conventional method? You need to find the total and divide it by 6. What's the total? The total would be 65 into 5 plus 70, right? This is the initial total because you had 5 games and the average was 65. So the total is 65 into 5 plus 70, which is the minutes run in the 6th game. And then you need to divide it with the total number of games, which is 6. And that gives you this one over here. Again, if you calculate it, you will get the same answer. But this logical approach of solving these type of questions, it is much faster. All right. Now, let's keep this aside and let's go to the next question. The next type of question. So it's given that after the 5th game, the average is 65, right? And after the 6th game, the average became 66. All right. Now over here, I have my 5 games, which initially gave an average of 65. So I can write 65 in each of these circles, right? Because remember, average is the number that can replace every number in a set of numbers without changing the total. All right. Now, let's say that we have over here the 6th game, right? And some amount of minutes were run in the 6th game. Now, after this happened, the average changed to 66. So this scenario, I can represent it as 6 circles in which each of the circles is filled with 66, right? Because this is my new total. 66 into 6 is my new total. All right. Now the question is, how many minutes should I have inside over here, that is the 6th game, such that I can change the total into this type of a scenario where if I put 66 in each of the games, then the total is the same, right? So all right, so let's get started with putting 65 over here. So when I have 65 over here, that's equivalent to having an imaginary scenario where the 6th game had also 65 minutes, right? Now if we ran 65 minutes in the 6th game, then the average would have been 65 itself, right? Now we need to change this scenario from over here, the top line, to this scenario, right? So what's the change over here? Everywhere you can see that you need to add 1, right, to get 65 to 66. So that's an increase of 6 into 1, and that has to be added to 65 over here. So 65 plus 6 into 1, that's equal to 71 minutes, right? So that gives you the answer. If the average has to change from 65 to 66 in the 6th game, it should be running 71 minutes. Now, can you tell me the conventional approach to solve this question? The conventional approach would be, you just need to find the difference of the sums, right? So what's the sum in number of minutes run till the 5th game was over? That would be 65 into 5, right? And what is the sum after the 6th game was over? That would be 66 into 6. So if you do 66 into 6 minus 65 into 5, still you will get the answer as 71. But you can see that approaching this question using this logical manner is much faster and it will help you to solve these type of questions very quickly. Let's do this question. It's given that after 30 games, the average minutes that a person is running is 50 minutes. Now, it's also mentioned that after 35 games, the average minutes of running is 55 minutes. Now, the question is, what's the number of minutes ran in the last 5 games? All right, pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now, we will be approaching this in the logical manner. That's the fastest way to solve these type of questions. Now, over here, it's given that after 30 games, the average is 50 minutes, right? So I can visually represent this as 30 circles, and in each circle I can put the number 50, right? 50 minutes. All right. Now over here it's mentioned that after 35 games the average is 55. So this over here can be visually represented with 35 circles, and in each circle I put 55, right? Because that's the average over here. Now the question is, what's the minutes ran in the last 5 games? So you need to change this scenario to this scenario over here. So what's the number of minutes that we need? We need 5 more circles over here, imaginary circles, where we put 50 first, right? So that would be 50 into 5. Why is that so? Because over here we have just 30 games and over here we have 35 games. So let's add 5 circles, imaginary ones over here, and in each we put 50. So that's a total of 50 into 5 minutes, right? Now we need to change this scenario to this scenario. That's an increase of 5 minutes in each of these, right? So that's 5 into how much? That's 5 into 35, right? Because over here you have 35 circles. So 5 into 35. So this will give you the answer. That's 250 plus 175, which is equal to 425 minutes. And that is your answer. All right. What's the conventional way of solving it? It would be 55 into 35 minus 30 into 50. That will also give you the same answer. But this is much faster if you can mentally visualize this, right? If you're actually solving it in a problem, you don't need to draw it and all. You can visualize it mentally and you can solve it much faster in this method. Now, if the question had asked you to find the average in the last 5 games, what would that have been? That would have been 425 divided by 5. That would have given you the average number of minutes that this player runs in the last 5 games. Let's do this question. A player scored an average of 55 points after playing a certain number of games. After playing one more game in which he scored 91 points, his average becomes a prime number less than 65. Find the total number of games he played. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, let's take that the initial number of games that he played is X. So then we can say that it's given that after X games, his average was 55, and after X plus 1 games, the average is a prime number less than 65. Alright, now we also know that in the X plus 1th game, he scored 91 points, right? It's given over here. So what would be the new average? The new average would be 55 plus 36 by X plus 1, right? How is this? Try to visualize it. Over here, we have X games, and in each of these games, I can put the number 55 because that's the average, right? Now, over here, it's also mentioned that in the next game, he's scoring 91, and let's try to visualize what would be the new average. So I put a set of balls over here. So I should have X plus 1 balls over here, right? So how much can I put inside each of these balls or circles? So we start with putting an imaginary circle over here, and I put 55 inside this, right? So that's this 55 over here. Now I have how many points left? I would have 91 minus 55 points, right? Because I've just used up 55 points, and to start with I had 91 points. So I'm left with 36 points, and these 36 points have to be equally distributed among these X plus 1 circles, right? So that's why 36 by X plus 1, and hence the new average is 55 plus 36 by X plus 1. Now we need to find what the number of games that he played is, right? That's X plus 1, which is what we need to find out. Now to solve this, the best way is to check the options. And how do you do that? This has to be a prime number less than 65, right? Therefore, X plus 1 has to be a factor of 36, right? Because it has to perfectly divide 36 so that you don't get a decimal value. You should be getting a number, and you need to check the options where you get a number such that the new average is a prime number less than 65. So by checking the options, if you put option A, if X plus 1 is 9, 36 by 9 is 4, and 55 plus 4 gives you 59. And that's a prime number. So yes, option A works. What about option B? If you put 6 over here, 36 by 6 gives you 6, and 55 plus 6, that's equal to 61, and 61 also is a prime number. So yes, option B also works, and therefore the correct answer is option D, that is A or B. Alright, right? And how did we go ahead with this? We went ahead with this because X plus 1 has to be a factor of 36. That's what we saw. Alright, now let's also see this in a little bit greater depth, so that without the options, what would we have done? Let's see that over here. So what are all the options where I can have X plus 1 in a way that it's a factor of 36? So let's write all the factors of 36. That would be 1, 2, 3, 4, 6, 9, 12, 18 and 36, right? So these are all the factors of 36. Now, how do you do that? You know that 36 is 6 square. That's 2 square into 3 square, right? So that's 4 into 9. So that's also 36. So you just need to find all the possible factors. So I can take nothing at all. So 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 5 is not there over here, 6 is a factor, 6 is 2 into 3, and then 7 is not there, 8 is not there. For 8 you need 2 to the power 3, right? So 8 is also not there. 9 is there, you have 3 2s, so 9 is there. 10 is not there because you don't have 5 over here. 11 is not there, 11 is a prime factor and it's not there over here, right? So 12 is there because that's 4 into 3. Similarly, you can see you have 18 and then you have 36. That's one way in which you can write all the factors. And what's another way in which you can write the factors? Remember, factors occur in pairs. So if you want to write all the factors of 36, so just express 36 as a product of two numbers in all the ways possible. So that's 1 into 36. So you get this factor and you get 36 over here. And you can write 36 as 2 into 18, right? So you get this one over here and this one over here. You can write 36 as 3 into 12. So you get this one and this one. You can write 36 as 4 into 9, right? So that's this one and this one over here. And you can write 36 as 6 into 6. So these are all the ways in which you can write 36 as the product of two natural numbers. And with that, you can find all the factors of 36. Now, these are all values where we want to put x plus 1, right? Now, let's try. You cannot put 1 because in that case, x would be 0, right? If x plus 1 is equal to 1, x would be 0, but that's not true. After x games, he had an average of 55. So 1 is not true. Now, let's try all these values for x plus 1. If x plus 1 is equal to 2, right? So that's 36 by 2, you'll get 18, and 55 plus 18 gives you 73, right? Now, similarly, if x plus 1 is equal to 3, that's 36 by 3, that's 12. 55 plus 12 will give you 67. In a similar manner, you can write all the values over here, and we should be getting a prime number less than 65. So this is not less than 65. This is not less than 65. So we can check all these possibilities. Now 64 is not prime, so that's ruled out. And you can see 58 is not a prime number, that's ruled out. 57 is not a prime number. Why? Because it's divisible by 3. 57, 5 plus 7 gives you 12, right? So that's divisible by 3. So 57 is also not a prime number, and 56 is also not a prime number. So we are left with two options, that's 6 or 9 for x plus 1. And that is option D over here. Let's do this question. The average marks of 29 children in a school is 65. A new student joins the school with 80 marks. Find the new average. Alright, pause the video, give it a try, and then let's do it together. Alright, let's do it together. Now, it's given that the initial average is 65, right? And try to visualize it, okay? So you have 29 circles, and in each of these circles, you can put 65, right? Now, a new student joins and he has 80 marks, and we need to find the new average, right? So we start with putting an imaginary circle over here, and we put 65 over here so that we maintain the initial average, and we have consumed 80 minus 65, right? So we are left with 15, and that has to be evenly distributed out. So what's the new average? The new average would be 65, which is this scenario, plus 15 by 30, right? And what's this 15 over here? That's 80 minus 65, right? Because we just used up 65 marks over here. We are left with 15 marks, which has to be evenly distributed among 29 plus 1. That's 30 children. So the new average is 65 plus 15 by 30. That's equal to 65.5. That is your answer. Let's do this question. The average age of children in a class of 39 students is 15. If the age of the teacher is also considered, the average is 15.5. Find the age of the teacher. Alright, pause the video, give it a try, and then let's do it together. Alright, I hope you've given it a try. Let's do it together now. We'll approach this question both with the shortcut as well as the conventional method. Now let's start with the conventional method. You just need to find the new sum and divide it by 40 to get the new average, right? So that would be 39 into 15 plus x divided by 40 is equal to 15.5, right? This is the age of the teacher and this is the old sum. you have 39 students and the average was 15. So the old sum is 39 into 15, and you add the age of the teacher and divide by 40 to get the new average. Now you can solve this as 39 into 15 plus x is equal to 15 into 40 plus 0.5 into 40, right? So what am I doing? I'm just splitting this 15.5 as 15 plus 0.5 and multiplying with 40, and then you can distribute it like this. So that's 40 into 15 plus 0.5 into 40. So that's what I've written over here, and that's just to solve it easily, because over here also you have 39 into 15 and over here you have 15 into 40. So you can solve this as x is equal to 15 into 40 minus 39 plus 0.5 into 40, right? And this is equal to 20. So therefore, and this is 1 into 15, which is 15. Therefore you get that x is equal to 15 plus 20, which is equal to 35. So that's the conventional method with which you solve this problem. All right, now let's try to see the shortcut. Now, when we took the age of the teacher also into consideration, what is the change that happened? The change is it went from 15 to 15.5, right? So that's an increase of 0.5. All right, and what's the population? You have a total of 39 plus 1, that's 40 people, right? So there is a change in 0.5 and the population is 40, right? So remember, try to visualize it in terms of circles and the value inside. So the change over here is 0.5 into 40, right? So that's equal to 20, and therefore the age of the teacher is equal to the old average, that's 15, plus the change, that's 20. So 15 plus 20 gives you 35 as the answer. So can you try to visualize this over here? Now if you're not able to get the shortcut, let me try to help you with it. Over here you have 39 circles, right? And you fill each of these circles with 15. Now you have, in the next case, you have 40 circles and you fill each of these circles with 15.5, right? So you're changing from this scenario to this scenario, and we need to find what value can make this change, right? So we start by putting an imaginary circle over here and we fill 15 with it. So that's this 15 over here. Now the change in each of these is from 15 to 15.5, that's 0.5, right? And that has to be done for 40 circles over here. So that's 0.5 into 40, which is equal to 20, which is what we have over here. Therefore the age of the teacher is 15 plus 20, which is equal to 35, and that is your answer. Let's do this question. The average age of the employees in a company is 26 years. The company has 20 employees. One person quits and the new average is 25 years. Find the age of the person who quit. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now, we'll try to approach this question both with the conventional way and the shortcut. Now, the conventional way is you just need to find the new sum and divide it with 19, right? Because you had 20 employees and after one person leaves, you have 19 employees. So the new sum is 26 into 20 minus x, where x is the age of the employee who left, and you divide that with 19 to get the new average, which is 25. That's what's given over here. Now you can solve this as 26 into 20 minus x is equal to 19 into 25, or you can solve and you get x is equal to 45. So that's one way of doing it, but it's much faster if you approach it in the logical manner. So the change in the average is from 26 to 25. The change is equal to minus 1, right? Now over here I have the balls, right? And you can see that this is the initial scenario where the average was 26. Now one person is leaving, so you're left with 25 as the average and you have 19 employees, right? Now you can think of it in two ways. Now imagine it that you're going from the final scenario to the initial scenario. Over here you have a total of 19 balls, right? Now from here, if you want to go to here, so the average age over here is 25 and over here it's 26, right? So from here to here, if you're going, then you just need to find what to add. It's the same thing. If you're going from here to here, you have to find what to remove. So let's try both the approaches. So suppose you're going from here to here, which is the reverse, right? So you start by putting an imaginary ball over here. You put 25 inside it. So that's your 25 over here. And you need to make a change of 1, right? The change is 1, and that has to be done for 20 employees. So plus 1 into 20, that gives you the answer as 45, which is the same thing that we got over here, right? Now imagine that you're going from here to here. What would be the approach in that case? In that case, over here, we are removing the 26, right? In this case, the average is 26. So each of these balls would have 26 written inside it, right? So we are removing this ball. So that's 26, which is what we are removing. And then when we consider the remaining 19 balls, that's this part over here, right? So over here, we have 26 inside each of them. And over here, we have 25 inside each of them. So there is a change of 1 across 19 balls, right? Over here you have just 19 balls. So 26 plus 1 into 19, this also gives you the answer as 45. So in both the ways, whether you're taking it as the reverse approach where you're trying to add a person and get the average to change from 25 to 26, or you go in the approach of the question where you're removing one person, so that's 26 over here, and there's a change of 1 across 19 more employees. So that's 1 into 19. In both the cases, you get the answer as 45. Let's do this question. John analyzed the number of goals scored by 16 football players. He found that the average number of goals scored is 6. The maximum number of goals scored by a player is 10. The minimum number of goals scored by these 16 players is 2. What can be the maximum number of players who scored at least 8 goals? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, the range of the goals scored by these 16 players is in between 2 and 10, and 2 and 10 being included, right? Because it's mentioned that 2 is the minimum number of goals scored and 10 is the maximum number of goals scored. Now it's also given that the average is 6, right? Now we need to find the maximum number of players who could have scored at least 8 goals. And remember, when you have at least 8 goals, this means 8 goals, 9 goals or 10 goals. Now, when you maximize this number, what is the criteria that you need to keep in mind? It's that the average is 6. So we need to maintain the average as 6. Now, when the average is 6, what would be the total number of goals scored? That would be 16 into 6 because there are 16 players. Alright, now let's visualize this part over here. That is, the average is 6 goals. Alright, remember, the average is a number that can replace every number in a set of numbers without changing the total. So over here, I have given 6 goals to each of these 16 players. Now, let's try to fulfill the given conditions. We need at least one player who scored 10 goals, right? Because it's mentioned over here. So let me change this 6 to 10. That's an addition of 4. Now to keep the total constant, I should subtract it over here, right? And this is permissible because after doing the subtraction, the number of goals scored by this player is 2 goals, and which is the minimum allowed over here. It's not below the minimum, so that's fine, right? So how many players have we consumed? We have taken into consideration 1 and 2. So we are left with 16 minus 2, that is 14 more players. Alright, now let's go on and fulfill this criteria over here. Now we need the maximum number of people who scored 8, 9 or 10, right? So to maximize it, let's maximize 8 because the number of goals with which we can distribute to each player is constant, right? So if I were to increase the number of players who scored 10 goals, that would be less than the number of players who scored 8 goals. So let's maximize the number of players who scored 8 goals. Now for that, this person, the average is 6. Let's increase that with 2. So I get to 8. Okay. So I have to subtract 2 goals from another player to make up for this increase so that the total is constant, right? Now, if I decrease it, somebody else would go to 4 goals, right? 6 minus 2 is 4. That is still within the limits. So let me increase one more person by 2 goals first. So that's 6 plus 2, 8. So I have to decrease a total of 2 plus 2, that is equal to 4, right? So let me do that over here. So 6 minus 4 gives me 2 goals, and that is within the permissible limits. All right, so we have taken 3 players, and out of these 3 players we were able to increase 2 players to the category of 8 or above goals. So how many more players are we left with? We are left with 11 more players. So we keep doing this process over here, taking 3 players at a time. Let me write that over here. Now I have 8 goals and 2 goals. Now over here I have taken 3 people and I've done this operation. So that is this set of 3 people, right? Now I can do this again one more time, and one more time. So this is a total of 3 into 4, 12 players, and we have 2 players over here, right? So 12 plus 2 is 14 players. Therefore, out of 16, there will be 2 more players left, right? So let these last two players be the last 2 players. Now over here, I could increase this person to 8 and I can decrease this person to 4, plus 2 and minus 2. Now if I wanted, I could have increased this person to 10 also, but again that would not change the number of players who scored 8 and above, right? All right, so let's now go to the question. How many people were we able to put into the league such that they scored at least 8 goals? So we have 1 person over here, we have 8 people over here, that is this 2, this 2, this 2, this 2, that's 8 people over here, and we have 1 person over here. So 1 plus 8 plus 1, that's equal to 10, right? And that is our answer, which is option B. Let's do this question. The average weight of 8 family members is 60 kilogram. If 2 family members move to a different country and 2 more family members are added to the house by way of marriage, the new average of the household is 58 kilogram. All right, so we go from 60 to 58. Now, the weight of the family members who moved to a different country were equal. So we treat this as X and X. Also, the weight of the 2 newly added family members are equal. So let's take it as Y and Y. It is also given that when 1 more family member whose weight is equal to the 2 newly added members, so that's Y, was added, the average was 58 kilogram. Find the weight of one of the members who moved to a different country. So we need to find the value of X. All right, pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now I can say that 8 into 60 minus 2x plus 2y by 8 is equal to 58, right? This is the new total, right? 8 into 60 is the old total when I had 8 family members and the average was 60. Now from that I subtract 2x, that's the 2 people who moved to a different country, and I add 2y, that's the 2 new people added by marriage, and so I have a total of 8 people. That's why I divide by 8 and 58 is the new average. Alright, now 1 more person was added and the average remained at 58, right? Therefore the weight of the 3rd person who was added has to be equal to 58, and it's given that that weight is equal to y itself, right? Therefore we get that y is equal to 58 kilogram. Now let me quickly explain this to you. Say you have 2 people whose average is 20. So let me draw 2 circles and I have 20 written inside it. Now it's given that 1 more person was added and the average remained at 20. So then the weight of the 3rd person who was added has to be equal to 20, right? Why is that so? What's the total over here? That's 20 into 2. What's the total over here? That's 20 into 3. So if you subtract these two, you get 20 kilogram itself. Therefore, the weight of the 3rd person who was added, and because the average did not change, has to be equal to the initial average itself. That's 20 itself. Alright, that's the same thing that we have applied over here, and we get that y is equal to 58 kilogram. Alright, let's proceed. So we get that y is equal to 58 kilogram. Now you could, the conventional ways you can just solve, right? If you substitute y as 58 over here, you can find the value of x, which is what we need to find out. Alright, now let's try to apply logic to do it faster. Okay, so I take this instance where I have 8 people and the average is 58 kilogram. So I can visualize it like this. I have 8 circles and in each of these I can write 58. Now we know that y is equal to 58. So definitely the last two people also have 58 kilogram over here, right? Now these people can be represented as 58 inside, though the value may be less than or more than 58, but the total will be maintained in this manner. So let me write 58 inside each of these 6 circles. All right. Now over here, the initial scenario was that I have 8 people and each of these have 60 kilogram as the average. So I can have 8 circles with 60 inside it, right? Now let's think of it in two ways. One way is that what's the difference that's happening over here? The difference is that it's a difference of 2, right? It's a difference of 2 in the case of 8 people, right? So the total difference is 8 into 2, that's 16, right? And that's a reduction of 16 because we are going from here to here, right? So that's a reduction of 16, and that's because 2x was removed and 2y was added, right? So 2x minus 2y has to be equal to 16, or you can solve that 2x is equal to 16 plus 2 into y, and y is 58 we know. So 2x is 16 plus 2 into 58, or you can solve and you get x is equal to 66. That's option B, which is your answer. Now you could also think of it in another way, which is that you're removing two guys who have 60 kilogram, right? So we are trying to find out the value of 2x. So these two guys are removed, right? And let's only consider this part over here. So what's the difference? It's 2 in the case of 6 people, right? So that's 2 into 6. Therefore 2x is equal to 2 into 60 plus 2 into 6, which is equal to 66 into 2, right? So you can get x is equal to 60 plus 6, which is equal to 66. That's again option B, which is your answer. Hi students, in this video, let's discuss about average age related problems. Say you have a group of people, and let's take that the average age of this group of people today is X. Alright, now after n years, their average age will be X plus n. That's because each of them will increase their age by n years. Similarly, before n years, their average age will be X minus n. Now there is a caveat over here. We need to see that none of them were not born at that time. Like if you have 5 people and one person is just 3 years old, and if you go 4 years back, one person would not have been born. Alright, we'll see those cases in practice problems. Now let me quickly show you why this part over here is true. I've given you a logical reason that each person increases in age by n years. Let's see that over here mathematically. Now let's say we have p number of people, then the total age when the average age is x years will be p into x, right? Now after n years, the total age will be p into x plus p into n, because each person increases in age by n years. So that is equal to p into x plus n, and if you take the average, that's p into x plus n by p, and you get x plus n as the answer. Now let's see these in detail in the practice questions. Let's do this question. The average age of 4 siblings is 12 years. The youngest child is 4 years old and second youngest child is 5 years old. What was the average age of the children 5 years ago? Also find the average age of the children after 6 years. Alright, so there are two parts to the question. Let's start with the difficult part. It's very easy to find the average age after 6 years, right? We have seen that you just need to add 12 plus 6, right? That's 18. Alright, let's start with the difficult part. That is the average age of the children 5 years ago. Alright, now what's the total age of these 4 siblings? That would be the average into 4, right? So that's 4 into 12, you get 48 years. Alright, now you can't simply do 12 minus 5 to get the answer, because there would be some children which are not born. Let's see that over here. Now what's the scenario 5 years ago? You have 4 siblings. Alright, now you can see that 5 years ago, the youngest child would not have been born, and the second youngest child would be 0 years old, and the others would be proportionately of lower age by 5 years. Alright, now let's find what the total age of these 2 siblings is today. So that's 48 minus the age of the youngest two children, which is 4 and 5 as per the question. So 48 minus 9 gives you 39. So that's today's age of the older two siblings. Now 5 years ago, the sum of these two guys' age would be 39 minus 5 minus 5, right? That's equal to 29 years. Why is that so? Because each would be 5 years younger, right? Now we need to find the average of these three children when the scenario is 5 years ago, right? That would be total by number of children, which is 29 divided by 3. Remember, it's not 2, it's 3, because even though this child is 0 years old, this child is still born. So that's 3 children. So the average is 29 by 3, and that is equal to 9 2 by 3 years. All right. Now, what would be the average after 6 years? That's straightforward. You just need to add 6 to 12, which is the current average, and that is equal to 12 plus 6, which is equal to 18 years. You could also do it like this: 4 into 12 plus 4 into 6 by 4, right? 4 into 12 is the current total, and each child increases by 6 years. That's plus 4 into 6, and there are 4 children, so you divide it by 4 and you get the same answer, which is 18. Let's do this question. 12 years ago, the sum of the ages of a household of 8 people added up to 200. All right. 4 years later, one member died at the age of 70. In the next year, a child was born. Another 4 years passed, and one more member died at the age of 70, and a child was born on the same year. All right. The current average age of the 8-member household is nearest to. All right. Pause the video, give it a try, and then let's do it together. All right. We are back. I hope you have given it a try. Let's do it together. Now, it's given that 12 years ago, the sum of the ages was 200, right? And it's mentioned that there were 8 people in the household. Now 4 years passed, and what happened? One person died at the age of 70, right? Now this 200, if nobody had died, after 4 years, it would be 200 plus 8 into 4, right? And because one person died at the age of 70, we have to do minus 70. So that gives us the total at this point of time as 162, and there are 7 members in this household. Now it's mentioned in the question that one more year passes. So what's the total age at this point? That would be 162 plus 7, right? Because there are just 7 members at this time. So 7 into 1 is 7. So 162 plus 7 gives you 169 as the total, and the number of members is 8 because a child was born in this year. Now 4 more years pass, and what's the total at this point? It would be 169 plus 4 into 8, and then you need to subtract 70 from that because one person died. So the total is 131, but the number of members is still 8 because though one person died, it's also mentioned that in the same year a child was born, right? So the total is 131 and the number of members is 8. Now we moved back 12 years, right? So over here we have moved 4 plus 1 plus 4. That's a total of 9 years we have moved ahead. So we have to move 3 more years ahead to come to today. So when you add 3 more years, the total becomes 131 plus 8 into 3, right? So that's a total of 155, and there are 8 members. So the average is 155 divided by 8, which is approximately 19, and that is option B. In this video, let's discuss questions related to average speed. Now, we will discuss more topics related to speed, distance, time in that section, but over here, let's just discuss average speed. Now, average speed is given by total distance traveled by total time taken. Now, remember, you must have observed that in a speedometer of a car or a bike, the speed is in kilometer per hour, and kilometer is for distance and hour is for time. So speed is distance by time, and average speed is given by total distance traveled by total time taken. All right. Now to illustrate this better, let me take an example. Over here we have 2 points A and B, and it's given that the distance between A and B is D, and say a person starts from point A, moves to point B at 40 km per hour, reaches point B, immediately turns back and gets back to point A at 50 km per hour. Alright, now we are asked to find the average speed of the person. Now, what's a common mistake that a lot of students do? The mistake is doing 40 plus 50 by 2. So this is wrong, okay? You cannot simply add the speeds and divide by 2 to find the average speed. The average speed is given by the total distance divided by the total time taken. And remember, speed is distance by time. Alright, so if you want to find time, because we need that for the denominator, time is equal to distance by speed. Alright, so let's try to apply that in this sample question. What's the total distance that he has traveled? He'll travel a distance of d when moving from A to B, and he will travel a distance of d when moving from B to A. So the total distance is d plus d or 2d, and the total time will be d by 40 plus d by 50, right? Why is that so? Because time is distance by speed, and over here when he moves in this direction, the distance is d and speed is 40 km per hour, and when he comes back the distance is d and speed is 50 km per hour. So the average speed is 2d divided by d by 40 plus d by 50, and this simplifies to 2 into 40 plus 40 into 50 divided by 90, right? And that's equal to 400 by 9 km per hour. So this is the average speed. Now let's see some interesting questions relating to average speed. Let's do this question. Thomas covers the first 1/5 of the distance to school walking at 2 km per hour. He runs at 3 km per hour for the remaining distance. Find his average speed for the whole journey. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Let's start with drawing a rough sketch. Okay, so it's given that 1/5 of the distance is traveled at 2 km per hour, and the remaining part, that would be d minus d by 5, which is equal to 4/5d, is traveled at 3 km per hour, and we need to find the average speed for the whole journey. Alright, now speed is equal to distance by time, and therefore time is equal to distance by speed. And remember, average speed is total distance by total time taken. So in this case, the total distance is d, and the total time taken is the time taken for this part of the journey plus the time taken for this part of the journey. So the time taken over here will be distance by speed. Distance is d by 5 and speed is 2 km per hour. And over here the distance is 4/5 into d and speed is 3 km per hour. So the average speed is given by d by 5 by 2 plus 4/5d by 3. And this simplifies to 1 into 2 into 3 divided by 3/5 plus 8/5, right? Over here you can see this d and this d over here gets cancelled out. And this simplifies to 6 into 5 divided by 11, which is your answer. And this simplifies to 2.7 km per hour, which is option D over here. In this video, let's discuss an application of averages in number series. Now, if you take the sum of the first n numbers, that's 1 plus 2 plus 3 up to n, that's equal to n into n plus 1 by 2. Now, we learn more about this in the section in numbers. Alright, now let's take this as a given. Now, if you want to find the average of the first n consecutive natural numbers, that would be the sum of the first n natural numbers divided by the number of numbers, that's n, because we are taking the first n consecutive natural numbers, right? So that is equal to n into n plus 1 by 2 divided by n, which gives you n plus 1 by 2. So let's see an interesting question where we apply this. A is equal to the average of the first 100 natural numbers, alright? B is equal to the average of the sum of the first 999 natural numbers. Find the value of B minus A. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, A is the average of the sum of the first 100 natural numbers. So 1 plus 2 etc. up to 100. We know this is equal to 100 into 101 by 2. And over here we have 100 numbers. So we need to take the average. So this sum has to be divided by 100 and we are left with 101 by 2, right? So A is equal to 100 plus 1 by 2, that's n plus 1 by 2, and that gives us 50.5. Now B is equal to 999 plus 1 by 2, which is equal to 1000 by 2, which is 500. Now the question is, what's B minus A? So B minus A will be 500 minus 50.5, which is equal to 449.5. So this is a time saving thing. It's good to connect different parts of the topic. So that's why we bring something related to number series also over here. Hi students, in this video, let's try to understand what we mean with weighted average. Now, let's take a scenario. Say you have three groups whose individual averages you know, and you are asked to find the combined average. Now in this scenario, you would be using weighted average. Now let's take an example. Over here I have class 6, class 7 and class 8. Now let's say there are 20 students in class 6, 30 students in class 7 and 25 students in class 8. Now we found the average height for each class. Say the average height for class 6 was 140 centimeter, for class 7 it's 145 centimeter, and for class 8 it's 150 centimeter. Now we are asked to find the combined average height for class 6, 7 and 8. In that case, we would use the weighted average to find the answer. So the combined average would be equal to 20 into 140 plus 30 into 145 plus 25 into 150 divided by 20 plus 30 plus 25. Remember, average is sum by number of items, right? Now 20 into 140 will give us the total sum of the height from class 6. Similarly, 30 into 145 will give us the sum of the height from class 7, and 25 into 150 will give us the sum of the height from class 8. So when we add these three up in the numerator, we get the sum of the heights, and in the denominator we need to add 20, 30 and 25 to get the total number of people in this case. So there are 20 students over here, 30 over here and 25 over here. So there is a total of 20 plus 30 plus 25 people, and this expression over here will give us the combined average. Now let's see one more way of thinking about the weighted average. Now let's say that you are writing an exam for which you have three subjects. Alright, now let's say that these three subjects are maths, English and history, and it's mentioned that for this examination the weightage is 2:1:1. Alright, so maths has twice the weightage as English and history. Now say a child wrote the exam and they got their marks. They got 90% for maths, 80% for English and 85% for history. And we have to find the average score for that child in that exam. So the average would be 90 into 2 plus 80 into 1 plus 85 into 1. So we are multiplying each mark with its weightage. So 90 into 2 plus 80 into 1 plus 85 into 1 divided by the sum of the weightages. Now let me give you another way of thinking about it so that you will be able to understand it very well. Now when we say that the weightage of maths is twice the weightage of English, this score which the child got over here is equivalent to saying that in this exam there were two papers of maths, one paper of English and one paper of history. So why am I taking two papers of maths over here? Because the weightage is 2, and for English and history it's only 1. Alright, now let's take the same scores. So that would be saying that for maths the child got 90, over here again the child got 90, and then over here it's 80 and 85. So what would be the sum? The sum would be 90 plus 90 plus 80 plus 85, and the total number of papers would be 1, 2, 3, 4, right? Therefore the average in this case would be 90 plus 90 plus 80 plus 85 by 4, and you can see that these two are one and the same. So this is another way of thinking about weighted average. And what would be the answer in this case? The answer would be 345 by 4, which is equal to 86.25. Now let's dive deeper into weighted average with an example of a question. Let's do this question. School AIM has two divisions of class 10. Division 1 has 20 students and the average age is 13. Division 2 has 10 students and the average age is 14. What is the average age of both the classes? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now, Division 1 has 20 students and it's mentioned that the average age is 13. Now, Division 2 has 10 students and the average age is 14. So, the combined average of Division 1 and Division 2 will be sum by number of people, right? So, what's the sum over here? That's 20 into 13, right? The sum of the ages. And over here, it would be 10 into 14. So, the average is 13 into 20 plus 14 into 10 divided by 20 plus 10, right? So 20 plus 10 gives you the total number of children, right? Right? So this over here is equal to 400 by 30, which is equal to 13.33. And that is your answer, which is option C over here. Hi students, in this video, let's discuss mixtures and alligations. Now, this might be a new term, alligations. Now, what is alligations? It's actually just the reverse of weighted average. Now, let me take an example to explain this in a better manner. Alright, now let's say that there are 20 boys and their average marks is 40. Alright, and let's say we have 30 girls and their average marks is 60, and we are asked to find the combined average. We have already seen that the combined average can be found as 20 into 40 plus 30 into 60 divided by 20 plus 30, right? 20 plus 30 is the total number of people, and 20 into 40 plus 30 into 60 gives you the total marks. Alright, and you get the combined average as 52. Now say that in the question it was given that the average marks of boys is 40, alright, and it's mentioned that the average marks of girls is 60, and it's mentioned that the combined average is 52, and you're asked to find the ratio of the number of boys to the number of girls. This is where alligations come into picture. Let's see how to solve these type of questions. Alright, now over here we are given that the average marks of boys is 40, average marks of girls is 60, and the combined average is 52. So we write it like this. I write 60 over here, 40 over here, and 52 over here. Now I take the difference over here, the difference between 52 and 40, that gives me a difference of 12. I write that over here. And the difference between 60 and 52, that's equal to 8. So I write that over here. Therefore, over here I get that the ratio of the number of boys to the number of girls is equal to 8 by 12, which is equal to 2 by 3. So over here we have taken 8 because that's what's below 40, which is the case of the average marks of boys. And we are asked to find the number of boys by the number of girls. That's why 8 is in the numerator and 12 is in the denominator, and the ratio should be 8 by 12, which is equal to 2 by 3. Now, that means that if the number of boys was 2 and the number of girls is 3, and the average marks of boys is 40 and average marks of girls is 60, the combined average would be 52. Now, instead of 2 by 3, we could also take the number of boys as 4 and the number of girls as 6, or 8 and 12. It's the ratio that is constant. It's not the absolute number in this case that matters. In this video, let's solve 3 types of important questions related to alligations. The first deals with profit and loss related questions. The second one is related to mixture of liquids. And the third one is related to percentage. Alright, now let's dive into the questions. A shopkeeper buys 2 types of grains, one costing $10 per kilogram and another costing $15 per kilogram. He mixes them to get a variety of grain costing $13 per kilogram. Now the question says, in what ratio did he mix the two varieties? Pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, we arrange these values. We have $10 per kilogram, $15 per kilogram, and the resultant mixture is of course $13 per kilogram. So we write 10 over here, 15 over here, and 13 over here. Now the difference between 10 and 13 gives you 3, and the difference between 15 and 13 gives you 2. Therefore, the two varieties have to be mixed in the ratio 2:3. That is, grain of cost $10 by grain of color $15 is equal to 2/3. Let's go to the next question. Let's do this question. A shopkeeper sells two types of tea. TA has milk and water in the ratio 1:2 and TB has milk and water in the ratio 3:2. In what proportion should he mix TA to TB to get tea in which milk and water are in the ratio 1:1? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, in these type of questions, either consider only the proportion of milk or the proportion of water only. Alright, so let's proceed just taking milk of tea of type A and tea of type B. Remember, you could have done this question taking water only also. Alright, now if we consider tea of type A, the proportion of milk to water is 1:2. That means if I take 1 liter of TA, how much liters of milk will I get? I would get 1/3 liters of milk, right? How do you get that? That's one portion out of 3 parts. Over here the ratio is 1:2, so the sum of 1 and 2 is 3. So you divide the liter of milk into 3 equal parts, alright, and one part of that will be milk. So that's what we mean with 1:2. That's how we get this ratio over here as 1/3 for milk when it comes to tea of type A. Alright, what about tea of type B? The ratio of milk to water is 3:2. So you divide the 1 liter of tea of type B into 5 equal parts. 3 plus 2 is 5. Alright, so consider that these are equal parts. This is 1, this is 2, this is 3, this is 4, and this is 5. So you have 5 equal parts. Out of that, 3 parts will be milk. So this is milk, and this is milk, right? So visually you can see that this is nothing but 3/5 of the quantity of tea of type B, right? So the milk quantity in TB is 3/5. Alright, let me make some space over here. Now we have established that the proportion of milk in TA is 1/3 and the proportion of milk in TB is 3/5. Now we need to find out in what ratio I can mix these two types of tea so that the resultant ratio of milk to water will be 1/1. Remember, 1:1 is the same as having a milk ratio of 1/1 plus 1 with respect to the same method that we followed over here, right? This is equal to 1/2. Alright, now let me write these two ratios over here. So I have 1/3 and I have 3/5. Now the resultant mixture of TA and TB should have milk and water in the ratio 1:1. So in that mixture, the proportion of milk would be 1/1 plus 1, which is equal to 1/2. Alright, now let's proceed with the method that we discussed using mixtures and alligations. Alright, so we find the difference between 1/3 and 1/2, that's equal to 1/6, and the difference between 3/5 and 1/2 is equal to 1/10. Remember, how do we do this? Let me show that over here. 1/3 minus 1/2. Okay, 1/3 is the lower number. So remember, we are just trying to find the difference. So let's find 1/2 minus 1/3. It doesn't matter in which order we take it. Now 1/2 minus 1/3. For doing this, you multiply 3 with 1, you get 3 over here. 2 with 1, you get 2 over here. So 3 minus 2 is the numerator, and 2 into 3, that's equal to 6. So that's how you get 1/6 over here. Now how do you get 1/10 over here? That's the difference between these two, right? So let me have 3/5 minus 1/2. Again, 3 into 2 is 6. So you write 6 over here, minus 5 into 1 is 5. And then in your denominator, you have 5 into 2. That's 10. So that's how you get 1/10 over here. Alright, so we have found that we need to mix TA and TB in the ratio 1/10 is to 1/6. Now remember, you need to have the right order. The question says TA to TB, and this was what we found for TA, right? and this is what we found for TB. That's why I'm writing 1 by 10 is to 1 by 6. If in the question it was TB to TA, you should have written 1 by 6 is to 1 by 10. Alright, now let me multiply this throughout with 60. Now 1 by 10 into 60 is 6 and 1 by 6 into 60 is 10. So this ratio is the same as 6 is to 10, which is the same as 3 is to 5. Therefore, the correct answer to this question is 3 is to 5. Bob has $10,000 as savings. He invests part of it at 5% per annum simple interest and the remaining amount at 10% per annum simple interest. At the end of 2 years, he gets $1,200 as interest. Find the amount he invested at 10% per annum. Pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, you need to know that simple interest is equal to PTR by 100, where P is the principal, T is the time, and R is the rate. So simple interest is equal to principal into time into rate by 100. Now we'll see more of simple interest and compound interest in a different section, but I am just bringing it over here so that I can interrelate various dependent topics, and we will see how one method can be used in questions coming from different topics. Alright, now let's take this as a given that simple interest is equal to PTR by 100. Now in this case, it's mentioned that he got an interest of 1,200 for 2 years, right? So that's 1,200 is equal to 10,000, which is the principal, into T, that's time. So 2 years is the time. So 2 over here into R by 100, right? Alright, now therefore on solving this, you can see that R will be equal to 6% per annum. Alright, so the resultant interest that he got through his investment is 6%. Now some amount was invested at 5% per annum and some amount was invested at 10% per annum. Now we arrange 5, 10 and 6 in this manner. The difference between 5 and 6 gives you 1 over here, and the difference between 10 and 6 gives you 4 over here. Therefore, the ratio of the amount invested at 5% to the amount invested at 10% is equal to 4:1. Now we know that the sum of this, the total of this is $10,000 because that's the amount that he invested together, right? So what do? Divide 10,000 into 4 plus 1, that is 5 equal parts, and take one part to find out how much was invested at 10% per annum. Alright, so that is equal to 1 divided by 1 plus 4 into 10,000, that gives you $2,000. So he invested $2,000 at 10% per annum, and that is your answer. Now just for fun, let's find this part also. So this would be, you divide 10,000 into 5 equal parts and you take 4 parts. That is equal to 4 divided by 5 into 10,000, and that's equal to $8,000. So you can see that he invested $8,000 at 5% per annum and $2,000 at 10% per annum. Let's do this question. In a startup, there are 120 employees. The average age is 25. If the number of females increased by half of its previous number and the number of males becomes 3/4 of its previous number, the total number of staff remains unchanged. The new average age is 22 years. Also, it was observed that the average age of males and females remained unchanged. Find the average age of males now. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now let's take the average age of males as M and the average age of females as F. Alright, and let's take the number of males as capital letter M and the number of females as capital letter F. Alright, now over here it's mentioned that the number of females is increased by half of its previous number. That is, if it's F over here, it's increasing to 3/2F, right? That's F plus F by 2, which simplifies to 3/2F. Alright, and it's also mentioned that the number of males becomes 3/4 of the previous number. So M changes to 3/4 of M. So let me call this as F dash, and M dash for clarity. Alright, now over here you can see that the number of females increased and the number of males decreased, right? And it's mentioned that the total number of staff or employees remains unchanged. Therefore, the increase in females is equal to the decrease in males, right? So over here the increase is F by 2, the decrease is M by 4, right? It's increased by half, and from M, if you want to go to 3 by 4 M, you have to decrease it by M by 4. That means F by 2 is equal to M by 4, or F is equal to M by 2. That means the initial number of females is half the initial number of males. Alright, now let me keep this aside. Now over here it's mentioned that initially the average age was 25, right? And the average age of males is taken as M, the average age of females is taken as F. So we can arrange M and F and 25 in this manner, and we know that the number of males and females is M and F, right? So M and F, we know over here, are in the ratio 2:1, with males being twice the number of females. So over here I write 2:1. Alright, now over here we have seen that F becomes 3 by 2 F, right? And M dash is 3 by 4 M. Now if M is equal to X, right? So this over here becomes 3 by 4 X, and this over here becomes 3 by 2 into X by 2, because over here F can be replaced as X by 2. If M is X, F is equal to X by 2. Alright, so what are the proportions? It's 3 by 2 into X by 2 and 3 by 4 X, right? And it's mentioned that the average age of males and females remains unchanged. So even in the case where the change in number of employees has happened, the average age of males is still M and the average age of females is still F. So I can write M, F and 22 in this manner, because that's the new average age. And over here this is 3 by 4x and this is 3 by 4x. So that's 1:1 ratio in which the number of males and females are there. Alright, now over here we know that the total number of employees is 120, and in initial case the number of males to number of females is 2 by 1, right? So you can find out how much this is by dividing 120 into 3 equal parts, and you take 2 parts from that. Let's do that over here. So that would be 2 by 2 plus 1 into 120, and that's equal to 80. And if this is 80, this will be 40, right? Now after you do the increase in females and decrease in males, the total number of staff is still 120, but the ratio is 1:1. Therefore the number of males is 60 and the number of females is 60, right? Because you have 120 staff or employees and you need to divide it such that half are male and half are female, or you divide it into 2 equal parts. That's 1 plus 1, and you take 1 part. So that's 1 by 2 into 120, which gives you 60 over here. Similarly over here also you get 60. Now let's quickly solve this without actually making these into equations. We'll see how we can do that, and later we'll also see how you can make these into equations and solve them. Alright, when the females increased, the average age reduced, right? So that means that the average age of the females has to be less than 22, right? Over here you can see that males and females, the average age when taken together, we got 22. So one has to be greater than 22 and the other has to be less than 22. And in this case, when we increase the number of females, the average age of the total reduced from 25 to 22. That means the average age of the females is on the lower side. Hence, the average age of the females has to be less than 22 and the average age of the males has to be greater than 25. Alright, because over here we have M and F. So one has to be greater than 25 and one has to be less than 25. Now we have found that when we increase the females, the average age reduced. So the female age average has to be lower side. Hence, the average age of the males has to be greater than 25. And when we look at the answer options, there is only one answer option where the average age of males is given as greater than 25. That's answer option B, and hence the correct answer is 31. We can also solve it algebraically. Let's see how we can do that. Let me take these two parts over here. So we know that initially the average age was 25 and the ratio of males to females was 2:1, and later the average age became 22 and the ratio of males to females was 1:1, and it was also mentioned that the average age of males and the average age of females did not change, right? So I'm having here M and F, and over here also I have M and F. Now let's try to make this into equations. Now remember, over here one value among these two is less than 25 and one value is greater than 25. Over here also one value is less than 22 and one value is greater than 22, right? All right, so let's make them into equations. So over here, let's start with this part. I can write M minus 22 by 22 minus F is equal to 1 by 1, right? That's what we get the ratio over here, right? So I can simplify this as M minus 22 is equal to 22 minus F, or M plus F is equal to 44. All right. Now you can notice that even if I took the reverse, if I did not know which one was greater or which one was smaller, if I had taken it as 22 minus M by F minus 22, that's equal to 1 by 1, I would still have got the same answer, because this is nothing but multiplying both the numerator and denominator with minus 1. All you have to remember is, in one case you have to put 22 first, that's this number over here, and in the other case it has to come second, right? And what's the logic behind it? It's because 22 is the average, so it's a value in between the value M and F. All right, let's proceed. So we have got one equation over here. Now let's do the same thing in the case of this alligation. So I can say that 25 minus F by M minus 25 is equal to 2 by 1, and let me cross multiply. So I get 25 minus F into 1 is equal to 2M minus 50, and this simplifies to 2M plus F is equal to 75. So we have two equations and two variables, so we can solve this, right? Let me substitute this part into this equation. So I get M plus F is equal to 75, right? Or M is equal to 75 minus 44, because M plus F is equal to 44. So M is equal to 75 minus 44, that's equal to 31. And if M is equal to 31, you can substitute M over here and you will get the answer as F is equal to 13. So the correct answer to the question is 31. Let's do this question. The office space Silicon House has 3 startups, A, B and C. The average age of A, B and C is 25 years, 28 years and 30 years respectively. The average age of A and B is 26 years, of A and C is 28 years. Find the average age of B and C. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, we have 3 companies A, B and C. Now let's take the number of employees in these cases as A, B and C, and it's given that the average age of A is 25 years, of B is 28 years and of C is 30 years. Alright, now when you take A and B together, the average is 26 years. So over here we have 25, we have 28 and the average is 26. So let's arrange that in this manner, right? Now the difference between 28 and 26 is 2 and the difference between 25 and 26 is 1. Therefore, the number of employees of A to the number of employees of B will be in the ratio 2:1. Alright, now let's take A and C together. So A is over here 25 and C is 30 and the average is 28. So 25, 30 and 28. 30 minus 28 gives you 2. 28 minus 25 gives you 3 over here. And this is the ratio between the number of employees of A and C. So this is A is to C. Alright. Now over here we have A by B is equal to 2 by 1. Over here we have A by C is equal to 2 by 3. Alright. So B is equal to A by 2. And similarly C is equal to 3a by 2. Therefore, B by C will be a by 2 by 3a by 2, and a by 2 and a by 2 cancel out, and you get B by C is equal to 1 by 3. Alright, so that's the ratio of number of employees of company B to the number of employees of company C. Now let me keep this aside. Alright, now we need to find the average age of B and C. Alright, so we know the average age of B is 28, the average age of C is 30. Alright, let me write that over here. And the ratio of number of employees of B to C is 1:3. So I write 1 over here and 3 over here. Now I need to find X, which is the average. Now you can do it in two methods. The first method is the method of weighted average, which we have already discussed. So you need to multiply 28 with 1, 30 with 3, and divide by 1 plus 3, which is the total number of employees, right? So 28 into 1 plus 30 into 3 by 1 plus 3, that gives you the answer as 29.5. Now let me show you one more method which is not as calculation intensive as this method, though this is also pretty much doable, but still there is one more easier method where you need to do even lesser calculation. Alright, so what's the difference between 28 and 30? The difference is equal to 2, right? Alright, now all you need to do is you need to divide this difference, that is 2, in the ratio 1:3. So how do you do that? So there is one part over here and 3 parts over here. So there are a total of 4 parts. So you need to divide 2 into 4 equal parts and you take one part out of it. So that is 2 into 1 by 4, which gives you 1 by 2. Now remember, when you take this part, this taking one part is for this side, right? So that is always related to the diagonally opposite number. So 30 and 1 go together. So you just need to subtract this 1 by 2 from 30. So 30 minus 0.5 also gives you 29.5, which is the answer. Now, if you had taken 3 parts, that would have been 2 divided by 4, dividing it into 4 equal parts, and into 3, taking 3 parts out, right? So that gives you 1.5, and that would be related to 28. So 28 plus 1.5 also gives you 29.5. Now remember, the average is in between 28 and 30. That is why from 30 I did minus 0.5, and from 28 I do plus 1.5. In either way, you get the answer as 29.5, which is answer option C. Let's do this question. 90 liters of milk is adulterated such that it contains 15% water. What percentage of this mixture has to be replaced with pure milk so that the concentration of milk increases to 95%? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here, initially the concentration is 85% of milk, right? Because 15% is water, that means 100 minus 15, that is 85% is milk. And we are replacing this with pure milk. So in pure milk, you have 100% milk, right? So over here in one case, there's 85% milk and there is 100% milk, and you're mixing it such that the resultant mixture has 95% milk. Alright, so the difference between 85 and 95 is 10, and the difference between 100 and 95 is 5. So that's a ratio of 1:2. Now over here, remember what exactly is happening is that you're replacing some of the mixture. So over here, let this be 90 liters of milk that is adulterated. You're taking part of it out and you're replacing. So at the end, still together you will have 90 liters after you do this operation, right? So this part over here should be 2 parts out of a total of 3 parts of this 90 liters, right? So divide 90 into 3 parts, that's 30 liters, and you take 2 parts, that's 60 liters. Or this is equal to 2 by 3 into 90, which is equal to 60 liters. And that is your answer, which is option A. Now let me show you one more method in which you can do this. Let me make some space over here. Alright, now initially we have 90 liters of milk and the concentration of milk is 85% and water is 15%, right? So that means out of 90 liters, 0.85 into 90, that's equal to 76.5 liters is milk. So milk is 76.5 liters and water is 13.5 liters, which is 15%, or that's 90 minus 76.5. Now later it should be 95%, that is 0.95 into 90, that would be 85.5. So after you do this operation, 85.5 liters should be milk and water will be 4.5 liters. Now say you start with this much of milk, right? And say you are taking out X liters. So in that X liters, 0.85 into X will be milk, right? So, and then you are replacing it with X liters of pure milk. So let's write the equation. We get 76.5 minus 0.85x plus x is equal to 85.5, right? So over here, what is this 0.85x? That's the amount of milk in X liters which you are taking out, and you are replacing it with X liters of pure milk, right? So when you solve this, you will get 0.15x is equal to 9, or x is equal to 60 liters, which is the same answer that we get over here. And the correct answer option to this question is option A, that is 60 liters. Now let's do one more question which is pretty similar to the previous question, but it's different. Let's read the question. 90 liters of milk is adulterated to such that it contains 15% water. How much pure milk is to be added to this mixture so that the concentration of milk increases to 95%? Now in the previous question, the mixture was replaced, but over here it's added. That's the difference. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now in this case, the concentration is 85%, and for pure milk, the concentration is 100%, right? And we need to get this to 95%. Let's write these numbers. We have 85%, 100% and 95%. Alright, now 85 and 95 have a difference of 10, 100 and 95 have a difference of 5. The ratio is 1:2. Till this point, it's the same as the previous question, but the difference over here is this one stands for 90 liters, and to this 90 liters we'll be adding more liquid of pure milk to get the final proportion of milk to 95%. In the previous case, the total was to be retained at 90 liters. Alright, so if this is 90 liters, that's one part, right? So two parts will be 180 liters. How do you do that? That's 90 by x. If this is x, that should be equal to 1/2, right? So we get x is equal to 180 liters, and that is your answer, which is option B. In this video, let's discuss a shortcut for a special type of problem. Over here I have a vessel, and in this vessel I have A liters of liquid A. Now out of this I take out B liters, okay, and I replace it with B liters of liquid B. So this is B liters which is taken out, and I'm replacing B liters itself, but it is liquid B. Now this operation is repeated n times, that is taking out B liters and replacing it with B liters of liquid B. This is repeated n times. Then the liquid A left in this vessel divided by the initial quantity of A will be equal to A minus B to the power n by A to the power n. And after n operations, the liquid A left in this vessel divided by the liquid B left in this vessel would be whatever we get over here divided by 1 minus this value, that is A minus B to the power n by A to the power n divided by 1 minus A minus B to the power n by A to the power n. Alright, we'll see more of this in a few questions so that you will be able to understand and apply this in relevant questions. Let's do this question. A bucket is filled with 100% milk 1/3 of the bucket is replaced with water. This is repeated 2 more times. What is the ratio of milk to water at the end of these 3 operations? Pause the video, give it a try, and then let's do it together. Alright, we are back. Let's do it together. Now over here you can see that the answer options is just ratio. It's not an absolute value. Alright, so we can assume any quantity of milk to make it easier for us. Instead of taking one milk, we'll get ratios, right? So let me take the initial quantity of milk as 30 liters. Alright, now 1/3 of 30 liters is 10 liters. So you have a bucket with 30 liters of milk. You're taking out 10 liters and you're putting water into it. And you're doing this operation 3 times, right? Now, therefore, milk left after the third operation divided by the initial quantity of milk, that would be given by a minus b to the power n by a to the power n, where a is equal to 30 and b is equal to 10, right? So let's apply that over here. We get and n is equal to 3 because there are 3 operations. So this is equal to 30 minus 10 to the power 3 divided by 30 to the power 3, right? So you can take the power out and take it as, you can take the power as common. So it becomes 30 minus 10 by 30 to the power 3, which is the same as 1 minus 1/3. That's 2/3 to the power 3, right? So this is equal to 2/3 to the power 3, which is equal to 8/27. All right. Now that's not the answer. Don't be tempted and mark option A as the answer. What's the question? The question says, what's the ratio of milk to water? It's not milk to the initial quantity of milk, right? So if there are 27 parts initially, currently only 8 parts are milk. So what are the remaining 27 minus 8 parts? They will be water. So milk divided by water is equal to 8 divided by 27 minus 8. That's equal to 8/19, and that is your answer, which is option B over here. All right. Now let's proceed and do one more question. There is a bottle full of coconut juice. 10% of it is replaced by Coke. Again 10% of the mixture is replaced by Coke. This is repeated 2 more times. What is the approximate final percentage of coconut juice? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Let's take initial coconut juice as 100 liters. Now 10% of 100 liters is 10 liters. So we are taking out 10 liters of coconut juice and pouring 10 liters of Coke into the mixture. And this is repeated a total of 2 times plus 2 times. That's 4 times, right? So the final coconut juice by the initial coconut juice is equal to, that's given by a minus b to the power n by a to the power n, right? Where a is 100 liters and b is 10 liters and n is equal to 4. So this becomes 100 minus 10 to the power 4 by 100 to the power 4. That's equal to 9/10 to the power 4, right? So what's 9 to the power 4? That's 9 into 9 into 9 into 9, right? 9 into 9 is 81 and 9 into 9 is 81. So you just need to find 81 square. And remember, we have seen in numbers how to find a square quickly. You can refer that section under numbers. So over here 1 square is 1, so you put 1 over here, and then 8 into 1 into 2, that gives you 16. So you have 6 over here, 1 is carry forward, and 8 square is 64 plus 1 is 65. So 81 square is 6561. And over here in the denominator you have 10 to the power 4, right? That is equal to 10,000. So you get 6561 by 10,000, and that is approximately 0.656, right? And if you want to convert that into a percentage, you need to multiply it with 100. So you get approximately 66% as the answer, and that is option E. In this video, let's discuss what we mean with median and mode. Now we have already seen what is mean. That's nothing but the normal average, which is what we have dealt with in previous videos. Alright, let's get to median. What is median? Median is the middle value of a set of numbers arranged in ascending or descending order. So it's the middle value. Let's take an example. Over here I have a set of numbers. That's 21, 27, 29, 22, 26. You can see that these numbers are neither in ascending nor in descending order. So the first step is you need to convert them into either ascending or descending order. Let's do that over here. So that's 21, 22, 26, 27 and 29. So this is the ascending order. The ascending order is nothing but the increasing order. And the descending order is nothing but the decreasing order. As a memory aid, you can see that descending and decreasing both start with D. Alright, now after having arranged the numbers over here, for finding the median, you just need to take the middle value, which is 26 over here. Now in this case, you had an odd number of numbers. Over here you have 5 numbers. That's why you can directly take the middle value. Let's take a case where you have an even number of numbers. So over here you have 7, 9, 2, 3, 6 and 1. Alright, now the first step is let's arrange them in ascending order. So that's 1, 2, 3, 6, 7, 9. And let's take the two middle values. That's 3 and 6 right over here. And you have to take the average of these two numbers. So that is 3 plus 6 by 2. That's equal to 4.5. And 4.5 is the median of this set of numbers. Alright, so we have seen what we mean with median. Let's also see what we mean with mode. Mode is nothing but the most frequently occurring number in a set of numbers. Let's take an example. So over here I have a set of numbers. You can see that 2 is occurring 3 times, which is the highest number of times, and hence the mode of this set of numbers is 2, or the mode is nothing but the most frequently occurring number, right? You can see that 3 is occurring only 2 times, 7 is occurring once, 9 is occurring once, 1 is occurring 2 times, 5 is occurring 1 time, 6 is occurring 1 time, and 4 is occurring 1 time. 2 is occurring 3 times. That's why the mode of this set of numbers is 2.